There we go. The limit of any constant, I'll use k, as x approaches any number. Doesn't matter what the number is. The answer is what? K. The limit of the constant is the constant. If I said to you, find the limit of 5 as x approaches 6. It says replace x with 6. Well, there is no x to replace it. It's going to be 5. The numbers doesn't change. What's the limit of negative 30 as x approaches 4? Still negative 30. What's the limit of 22 as x approaches 2 pi over 7? What do you think? 22. Doesn't matter what x approaches. What's the limit of negative 7 at x approaches sine of 15.7 degrees? Still negative 7. The limit of any constant is always the constant. Doesn't matter what you're approaching. Remember what I said today, to find the limits, the easiest way, use direct substitution. You replace x by that value. There is no x here. So that's rule number 1. Rule number 2, the limit of x as x approaches c. Well, I said direct substitution is the best way. So if you do direct substitution, what are you going to have? C. That's correct. And that's what this one is telling you. Try direct substitution. Replace x with c. So what's the limit of x as x approaches 4? Replace x with 4. You're going to end up with what? 4. What's the limit of x as x approaches 0? Direct substitution. Replace x with 0. What's your answer? 0. What's the limit of x as x approaches negative pi? Replace x with negative pi. What are you going to have? Negative pi. Now what about if you have 3x, 5x, 7x? I'll give you the rules. You really don't have to memorize them as long as you know how to use them there. But it says if the limit, I'll give you examples on them, of f of x as x approaches a is equal, I don't know, to L. Let's use that. And the limit of g sub x as x approaches a is equal to, what should we use for that? M? Okay, L and M. What's the limit of some k times f of x as x approaches a? K is a constant. What this one is telling us is if you have a constant times a function, you can take that constant, put it outside. So if you want, you can break it down to k times the limit of f of x as x approaches a. Well, we know what the answer to this. That's equal to what? L. See it? So this will be what? K times L. So what does that mean? If I come and I said to you, what's the limit of 5x as x approaches the 3? Direct substitution is the best way. 5 times 3 is what? 15. But if you don't like that idea, what this rule is saying, take the 5, put it outside, 5 times the limit of x as x approaches 3. And what is the answer to this? Isn't that a 3? The limit of x as x approaches 3? So 5 times 3, the answer is what? 15. Nobody in the right mind is going to break it down like this. We're just going to go direct substitution. 5 times 3 is 15. I want to show you these rules are there. I just go to examples. There's so many of them, and it's silly just to write them. If you have addition there, limit of 4x squared plus 3 as x approaches, pick a number again. Go ahead. 6. The quickest way to do direct substitution. 4 times 6 squared plus 3. And what is 6 squared? It's 36, right? Plus the 3. 4 times 36. Plus the 3 is 147. What our book is saying, if you want to, and again, as I said, nobody in the right mind will do that, but if you want to, you can take that problem and break it down, because you have addition. See the addition? You can break it down to 2 limits. The first one, 4x squared as x approaches the 6. Since you have a plus, add to it the limit of 3 as x approaches 6. And if you want to, you can take that 4 and move it to the front, because that's one of the rules right here. So if you want to, you can take that 4 and put it in the front there and make that 4 times the limit of x squared as x approaches 6 plus the limit of 3 as x approaches 6. And now find the answer to each one, and you should have the same answer. Oh. When x is 6, what's the answer to this? Isn't that 36? So it's going to equal 4 times 36 plus, what's the answer to this? The limit of any constant is what? The constant. Is that the same answer? Now, how many of you are really going to break it down to all these pieces? Probably none of you. You're going to go with the direct substitution. That is the quickest way. But the book says if it's addition, you can break them down to addition. If you have subtraction, you can make them 2 separate ones. If you have numbers in the front, you can take them outside. I'm not going to waste my time on them. I'm just going to go to the problem and do them that way, direct substitution. So if I give you this problem, I'll make things up here. The limit as x approaches 1 of x squared plus x plus 2 over x plus 1. I can break it down to the limit of the top divided by the limit of the bottom. I'm not going to do that. It will work fine. I can just try direct substitution. Direct substitution, here we go. Will give me what? What is 1 squared plus 1 plus 2 divided by 1 plus 1? That's 1 plus 1 is 2. 4 over 2. What's the answer? 2. Done. There is no reason to break it down. What is the limit of the square root of x minus 5 as x approaches 9 equal to. Try direct substitution. That will be the square root of 9 minus 5, which is what? 3 minus 5, and the answer is negative 2. What's the limit of sine of x as x approaches pi over 2? What are we going to use? Direct substitution. Sine, replace x with what? Pi over 2. What is sine pi over 2 equal to? 1. What's the limit of x cosine of x as x approaches pi? Direct substitution. Pi times cosine of pi. What is cosine of pi equal to? Negative 1. Very good. Pi times a negative 1. And what's the answer? Negative pi. What's the limit of tangent x over x squared plus 1 as x approaches 0? That'll be tangent 0 over what? 0 squared plus 1. What's tangent 0? Isn't that a 0? Sine over cosine. Yep, that's a 0. 0 over 1, what's the answer? 0. So your first step in taking the limit is always direct substitution. That is the first step. That's the quickest, easiest way. Don't waste your time on the other stuff. If it works, if you get an answer, boom. If you don't have an answer, if you got something over 0, we have a problem. Then we have to look for other ways. So let me try another one. The limit of x squared plus x minus 6 divided by x plus 3 as x approaches negative 3. Let's try direct substitution. That's the easiest way. Well, I see a little problem. What do we have in the bottom? 0. The top is going to be what? 9 minus 3 minus 6. That's 0 over 0. I don't care about the top, but I know when you have 0 on the bottom, that's always a problem. Can't divide by 0. So direct substitution does not work here. Should I go to the table? Maybe. But I don't like the table. So what's the other choice? See if you can simplify that. Algebra. Can I simplify this? Can I factor the top? So if you end up with something over 0, try to simplify it first. I can factor that. I think that's x plus 3, x minus 2, if you factor it. And what do you notice now? These two will cancel each other out. The question becomes the limit of x minus 2 as x approaches negative 3. Now try direct substitution one more time. So if the first time you end up with division by 0, that says that's not good. Can I simplify the problem? If you can, go ahead and simplify it, then try direct substitution. So what do we have? Negative 3 minus 2, which is what? Negative 5, bingo. There's an answer. Done. the limit of x squared minus 4 over x minus 2 when x approaches 2. First step is direct substitution. Direct substitution is what? 0 squared, or 2 squared, I'm sorry, not 0. 2 squared minus 4 over what? 2 minus 2. What is 2 squared? 4. 4 minus 4? 0 over 0. We got a problem. Before I go to the table, maybe I can simplify that. Can I factor that and simplify it? That's x minus 2 times what? X plus 2 as over x minus 2. And what do you notice? Again, these two will cancel each other out. You have the limit of x plus 2 as x approaches the 2. And what's the answer to that? Is that a plus 4? I have some space. I hope the person sent me their email about wasting paper is not watching. Because the next one's bigger. I have to go on the next page. I'm feeling guilty now.
Just recycle, you'll be fine.
I'll do the back side next week when he's not watching. How about the limit as x approaches 0? X plus 1 minus 1 over x. I don't have to try direct substitution. Just by looking at it, what are you going to have in the bottom? 0. You already have a problem. You know it's going to be a problem. I don't care about the top. Doesn't matter if the top is 0 or not. Won't do me any good. It happens to be 0, but who cares what the top is? Once you have 0 on the bottom, can't be. Got a problem. Can I clean that? Is there anything I can do to fix it? I can't factor that. That's a square root. So what do you think? Any ideas for a square root?
Square the top and the bottom.
Square the top and the bottom. Here's one problem with the squaring. I don't want to touch this paper. When you have a fraction, if you square it, remember, if you have a fraction, you want to make sure you don't change the value of the fraction. Let's say I have 1/2. So if I multiply the top by 3, I got to multiply the bottom by 3. Why? What's 1 times 3? 3 over 6. When you simplify that, do you end up with 1/2? Yes. Here's what happens when you square something. You say square the top and square the bottom. When you square the 1, what do you have? 1. When you square the bottom, what do you have? 4. Is that equal to 1/2? No. So when you have fraction, you really can't square the top and square the bottom, because you just changed the whole fraction. Mathematically, that's not correct. And even if it was correct, you're still going to have the square root. You're still going to have x squared in the bottom. That doesn't get rid of that. But mathematically, it's not correct. I just want to show you that part. So any other options?
Oh my god, that paper.
I'll use it for some. I'll flip it. I'll use it. Any other options? With the square root, there's something. There's a name for that method. Conjugate. Very good. The conjugate, I'll spell it out in case you want to research it. Is you're going to multiply the top and the bottom by the same thing, and which is the conjugate of this. And what's the conjugate of that? We change this sign. Anytime you have a square root, that's really the process. You're going to multiply by the conjugate. Oh, plus, change the sign, yep. This minus turns to a plus. If this plus, you turn to a minus. Notice I'm multiplying by 1, so the value of the fraction is not changing. Leave the bottom alone. Don't worry about it. That's x times the square root of x plus 1 plus 1. Now, why did we switch the sign? Because when you FOIL this one, when you multiply it out, use the FOIL method. When you multiply a square root by itself, what happens to the square root sign? Gone. Yep. This times this is what? Plus 1 times the square root of x plus 1, that's x plus 1. What's minus 1 times the square root of x plus 1? Minus the square root of x plus 1. And what is minus 1 times a plus 1? The minus 1. The reason we switch the signs, we use the conjugate, so these two will cancel each other out every single time. That is the reason. It's going to be exactly the same thing, but opposite. So what is left on the top? You have x plus 1 minus 1 over Can I simplify the top? This becomes the limit as x approaches 0. Now the plus 1 minus 1 will also cancel each other out. What's left? X. That x will cancel this x. See it? This x with that x. So you end up with 1 over the square root of x plus 1. That's a 1, not an x here. I wrote that wrong. Now try direct substitution. Try direct substitution. What are you going to have? 1 divided by the square root of 0 plus 1 plus the 1. 1 over 2. So the limit of that as x approaches 0 is going to be 1/2. If for some reason you can't remember this, you're doing a test, homework problem says, I can't remember this. You can always go to the last resort method, which is what? Make the table. It'll always give you the right answer. I bet you if I did the table there, I will get the answer. You'll see it going to 1/2 on both sides. The thing is, a lot of people don't want to write these numbers and test them in, but there's a quick way to do them. I'll show you that on your calculator. I'll do this with the table just to prove it does work. So if I can't remember the conjugate, and I go, I don't like this method, I'm going to go to the table. You can. You're approaching the 0 from the left side. Let's look at the left side first. So you're not at 0 yet. You're in the negative. Negative 0.1. Negative 0.01. Negative 0.001. Negative 0.0001. From the right side, let's try 0.1. 0.01. 0.001. 0.0001. This is how I cheat. I'll show you. I go to my calculator, TI-83, the cheapest one. I get this, I think, for 20 bucks on Amazon. I go y equals, and I type in that function. Parentheses, because I want the whole thing. The square root, I forgot to hit the second. The square root of what? X plus 1. Can you see it on the screen? Close that. Minus 1, close parentheses. That's the top. The square root. Actually, I closed it there. the square root of x plus 1 in parentheses minus the 1, the whole thing divided by x. So I type the problem. Now I'm going to plug in all these numbers in it. Okay. You see right over my, it says window, there's table set on your calculator. Table set. Second table set. You want to make sure you are in ask mode. So go down here. You don't want to be in auto. Auto will allow you to use 1, 2, 3, 4, 5, -1, -2 automatically. But you can't use your own numbers. They're going to give you 1, 2, 3, 4, x. I don't want to use these numbers. I want to use my own. So I need to go to ask. That's for the independent variable. That's for x. I want that to be an ask, and you hit enter. Now you're done. Leave the other one alone. Go back to table now and start typing your numbers. You want it for -0.1, hit enter, and there's the answer. 0.51317. -0.01, enter. 0.50126. -0.001, enter. 0.50013. -0.0001. What happened here? Where is it? Oh, you see it? 0.50001. The other number from the previous examples, that's why they're there. So where's that number going toward what? You can see it's going toward what? The 1/2, the 0.5. Now try it from the right side. Can you still see it? Try the 0.1. 0.48809. 0.01. 0.49876. 0.001. 0.49988. 0.0001. 0.49999. Where is that number going? To 1/2. So from both sides going to 1/2. My limit is approaching 1/2. So that's when you see me push the button on the calculator quickly. That's really the quick way of doing it. Now we have 3 special cases. You need to know these, the trig ones. Let me write them, and you can prove them by using the table here. And the first one is the limit of sine of x over x as x approaches 0. You know, if you try direct substitution, it doesn't work. But if you go to the table, you'll see that's going to a 1. Those are special cases. You can prove them by going to the table. I'm not going to waste the time on them. The other one, the limit of 1 minus cosine of x over x as x approaches 0. That's going to a 0. And the last one, which is I never use, but ready for this? The limit as x approaches 0 of 1 plus x to the power of 1 over x. You want to take a wild guess what that answer is? E. The 2.71828. The other two are really heavy, especially this one, the sine. We use that a lot. And so is this, but not as much. This is probably used 80% of the time. This is probably used 19.9% of the time. And this one, probably 0.1% of the time. So you don't see a lot of examples with this one. these two, this, especially that one, you see a lot more than this. Way more than that. This one, the busiest one, okay, once in a blue moon. Where they get you in trouble sometimes with this. Yeah, they're playing a game with us. They'll come in and says, what's the limit of sine 5x over x as x approaches 0? I can tell you it's not 1. 5? Why 5?
Because you can bring the 5 out of there. And
Can't. That's part of the x. That's part of that. That's sine of 5 of x. This is one thing, 5 of x. I can't separate the 5 and the x. You know. If this number was 5x, I'll be okay. I'll just do a change of variable. Notice if that number was 5x in the bottom, I'll be okay. Why? Because I just do a change of variable. I say, you know what? Let's let z is a beautiful letter here, equals 5x. Let z equals 5x. If I do that, I can make this problem the limit of sine z over z. And when x is 0, what is z equal to? What's 5 times 0? 0. That becomes as z approaches 0. Does it really matter if I call that x or z? So the answer to this is what? 1. So as long as these two are the same, you'll be able to use that by changing the variable and your answer will be 1. Well, these two are not the same. Can I make them the same? It's a fraction. Multiply the top by 5 and the bottom by 5. Right? Doesn't change the fraction. But now you want to take the 5 out? You can take this 5 out, but not that 5. Now I can pull this one outside here. And this is definitely a 1 by doing change of variable just like what I did here. So that's 5 times a 1. What's the answer? Which is 5. So that's how they play with these. A lot of times they don't make them matching, and your job is to match them first, do whatever you need to do. Once you get them to match, then you can solve it. Or
Professor?
yes,
Where did you get 1?
the answer to this.
No, but you said 5 times 1. So you just
Yeah, the answer to this box is 5 and 1. The reason it's 1 here, because I'm using that rule there by doing change of variable. If I didn't do that, notice, Ilana, if I just took this, the 5x, and I just use u here, for example, if I let u equals 5x, then I'll be able to write that problem, the limit of sine of u over u, and when x is 0, what's 5 times 0? As u approaches the 0. That's the same as this special case, and I know the answer to that is 1. So that's why I know the answer to this one is 1. 1 times the 5 in the front, and that's why the answer is 5. So I just played with the change of variable for that one. Another case, they might trick you. You might not see the sine of x over x till you play with it. They might give you a problem like this. The limit of tangent x over x as x approaches 0. And again, if you go direct substitution, you know it doesn't work because you're dividing by 0. So direct substitution, I know tangent 0 is 0. 0 over 0 is a problem. So you have to remember your trig identity. Tangent x, rule number 3 on the board here, is what? Sine x over cosine. So if I write that as sine over cosine, that's sine of x over cosine of x, the whole thing divided by what? Divided by x, right? So this becomes the limit of sine of x over cosine of x. When you're dividing by x, that's the same as multiplication by what? Isn't that 1 over x? And now I can break it down to two problems. I can say, you know what? That looks to me, I can write that, instead of leaving it the way it is, can I write that as sine of x over x times 1 over cosine x? Can I just take this one and rewrite it like that? It's the same thing. When you multiply fractions, the top times the top, the bottom times the bottom. And now I can take this and break it down to two separate limits. The limit of sine of x over x as x approaches 0 times the limit of 1 over cosine of x as x approaches 0. And let's find the answer to each one. This is the special case. What's the answer to this? That's a 1 times, I don't have a special case for this, but try direct substitution. What's direct substitution? That's 1 over cosine of 0. What's cosine of 0? Isn't that a 1 if you have your unit circle? Cosine of 0 is 1. 1 over 1 is 1. Bless you. My answer is 1. 1 times 1, which is a 1. So it's just a matter of playing with these. Try direct substitution first. If it doesn't, play with the algebra. Can I come up with an answer? If yes, it's perfect. If not, guess what? Last resort is the table. But that'll be my last resort for these problems. So really, when you have additions, you can break it down when you have multiplication to the limit of the first times the limit of the second. You need to know what the answer to each one. Once you have them, I know the answer to this, that's a 1. I don't know the answer to this, but I can do direct substitution, which is this, and that gave me a 1. 1 times 1, which is a 1. So these are the rule of the limits.